Video is connected to the October 16th remote class, which is our first foray into spatial analytic tools. We've spent the last few videos really learning some geometric-based tools, clip, erase, intersect, and union, how we combine different shapes and are then able to visualize the areas where there's overlap or where multiple shapes intersect, or how we remove one shape from another to map something new. This video is also in the geometric family as well, but a little bit different. This one's less about sort of overlapping area and more about proximity, right? So how we potentially use the relationship of where things are to one another to understand their distance, or to generate a shape showing their area of influence, for example. But before I do that, it will be the closest, the near, and the buffer data is what I'll use. I am remiss that I forgot to include something in the intersection video. There's one more sort of nifty trick you can do with intersect. And, to do it, just drag in the thing in the intersect that says streets dissolved. Should you choose to follow along. Intersect is also a great tool, not just for showing you sort of the overlap of polygons, but it's really cool for showing points of intersection with lines. It's a super common use of it, that you maybe will take either one layer and then it'll look at the sort of overlapping parts of that layer, or multiple. I could take roads and then I could take railroad tracks and intersect them. And what it can return to you is where the individual intersections are. So I could start getting points for areas of overlap, right? Intersection between things. And the only trick to doing it really is down here where it says output type, just select point, right? So I just dragged in the dissolved streets and I said point. Again, this is to show you that you can use this trick even on a single source line, right? That has multiple parts crossing one another. And if you do it, you'll come back with multiple sort of points at all of the different vertices, right? So that's kind of a cool output. I can start to see the different areas, and suddenly I'm now treating them as actual points, which is a cool thing. Right now, I previously knew that these two roads were here, but it was just these lines crossing. But now I have a shape file that represents that intersection, right? Which is sort of a neat and nifty thing to be able to do. And I'm actually going to keep that here, for this lesson of major roads, as I think it might be help me make sort of one of the next points I'll make when we're looking at distance and proximity. But I'll turn off the streets and the intersections for now and really focus on the other two layers I want to do for this video, which is places you may live and farmers markets. So let's play around with the symbology on these so they're easy to see. I'll click on farmers market, for example. And I'll just navigate down and try to find something that's like, I don't know, sort of farmer's market-y. Maybe there's an Apple or a grocery store or some little thing like that. Or, I'll just navigate till I give up and pick something sort of randomly here. Starting to lose my patience, farmer's market. You are going to be a restaurant, even though you're not a restaurant. That's just because that's what's easiest to me. So those are farmer's markets. And then I'm going to click on places I want to live, and maybe we'll make them like a nice red square. And point is, I'm going to evaluate a couple places where I may want to live. I'll zoom out and take a look at them. And, maybe what I want to know for each of those is, well, how far are they from a farmer's market? And that's a pretty common question that you'll ask here, right? What's the distance between two things? And this is something that will come back into play in a few weeks when we learn Network Analyst, because the idea of distance, well, it would depend on how one measures the distance. The more common and easier and sort of, step one way that we'll learn today is Euclidean distance, also known as the crow flies. Right, you are measuring distance between 2 points based on the straight line you could draw, imagining there was no objects in your way. That's fine, right? That is certainly workable. But what we'll learn in a few weeks is how we can change that so that we're perhaps measuring our distance not based on a straight line, but on where we actually would need to travel, the roads we would need to take to get from point A to point B. But there's a number of tools that we'll learn here that help you with distance and proximity. And they will largely fall in the, as you'd imagine, proximity category. What we'll learn here is near and buffer are going to be the two that we'll learn. We may pop into Thiessen polygons. At one point I may just demo what that looks like or push it off. But buffer and sort of near are the real critical ones here. And there's also this tool called Spatial Join, which is a huge part of next week. That's probably, outside of selections, in my opinion, the most useful tool that you will have in ArcGIS. And that also has a cool little component where you can take each place and not just measure how far you are from a farmer's market, but get the name of that farmer's market. So you could not just learn, I am X number of feet from a farmer's market. It happens to be this one, right? That's a new piece of information you could get. But for now, let's just show you the concept of near to begin with. All right, so I'll come into near. The input features is what you want to understand how far, like the place you want to see that you'd be leaving from, like where you're going to measure your distance from, and that would be the places you live, right? So I want to know for each place that I might live, where or how far. And the near features is the thing you want to measure your distance to, and so that would be the farmers markets. And you should notice there is no output. So anytime a tool does not have an output, all that means is that the information will be appended to the attribute table. And that's what will happen with near. Places you may live will have a new field that tells you how far you happen to be from a farmer's market. And so then you can run it, blah, 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 blah. Give it a second to do its thing. We'll open it up. In each of the places I want to live, there we go, right? It's telling you how far. Your first question should be, what are the units? And you can answer it by knowing the projected coordinate system, right? I can see that I'm projected in feet. I could right-click the places I may live layer and see that it's also feet. So this is telling me the number of feet that I happen to be from the closest farmer's market, right? So I could look at that. I could see that that's the closest one there. It's about 1,500 or so, not the closest, but that one is 1,500 feet or so. I could even then do some summaries, right, of all the places I want to live, on average, how far am I? I could go to statistics, right, and I can understand of all the places that I want to live, on average, they're about 3,200 feet, and the median distance is 2,100 feet. Right, so I've added a new piece of information to the attribute table that I didn't have previously, which literally tells me now how far I am from that farmer's market. So that's near, right? It's a good, quick sort of distance measurement tool. The other big sort of tool that you'll use in this area, in proximity, is the buffer tool. And buffer is by far, if not clip, the second, if not the first most sort of used tool. It's the one you'll remember the most. It's the one you'll rely on, and with good reason, right? Buffer allows you to actually generate an area of influence around each input. So I could take each place I want to live and maybe draw a buffer for a mile, and then I can start to do a very different equation. Then maybe I could try to select all of the farmers markets that are within a mile or a mile and a half, right? I'm mapping what's not quite there. I'm visualizing space in a new way, and I can actually start to see the area of influence. Buffers are a very common tool used to draw those areas of sort of influence or proximity around a central area. So if I were to come over to tools and pop to my buffer here and take that, and I'll drag in the places that I may live, and I'll just call that, point buffer. The only real thing that matters after this, and I'll talk about what these mean in a second, but the big thing that matters here is the like how you're going to be measuring your your buffer. And typically what you'll pick is like a static unit. So let's say maybe if I did here, 5280, which is, the feet in a mile, and I say that'll be in feet, I'd be measuring a buffer of 5,200 feet around each one. I'd hit run, and I'll start to get these uniform sort of buffers around each of the places that I might want to live. So that's a super cool concept, right? I now have a totally new shape that is a perfect radius around them that gives me sort of the area of influence. And now I can visually see something that was harder to see at first, right? I can visually see for each one how many farmers markets might be within that mile radius. Cool thing about when you buffer is it retains the attributes. So it's not like they're just these new random shapes. I know that, this buffer attached to that sort of place I want to live, that parcel, that address, that person who owns it, blah, 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 blah. That's a neat concept about the buffers, that they can sort of pull that information back. So the other thing with buffer is you can also use a field, right? So let's say each place I wanted to live has a different value you'd want to buffer. And this is a common use. I remember in Chicago a couple years, maybe 5 or 6 now, the government was doing a sort of food security analysis for communities in Chicago, just trying to understand at different parts of the city how far residents would be from farmers markets or supermarkets or grocery stores versus convenience stores, to try to understand where there were food deserts within the cities. And, they were mapping sort of service areas of grocery stores and corner stores and all that. And in that analysis, you sort of needed different buffers for each. The service area for a corner store is probably, half a mile or at a quarter mile, what you're going to walk to in that area, versus a grocery store. You maybe could say a grocery store service area could be 3, 4, 5 miles, right? So different things might have different buffers you want to put around them. And you can do that by doing field. So what I'll just do is, it's totally made up, but that near distance field we had, right, that totally random field that we just were measuring how close we were to a farmer's market, I'll just pretend that's a unit I want to do for buffering. And oops, don't pick linear unit, pick field, and then say the field you'd want would be, near distance. And, then I'll call you point buffer 2. And, if I ran this now, the things are going to look a little bit different. Right now, there's variable shapes for each of them based on the measurement that we had. So it's a cool concept that you don't just need to have sort of a static measurement. You can really sort of vary your buffers based on some information that you store in the field. So the last thing I want to show with kind of buffer, and I didn't plan well enough here, so I want you to come to clip and erase and drag in the outside. And so then let's open, this is an interesting one, round. So you can open buffer again, and next we can actually drag in the polygon, right? So what if we were to drag in outside instead, and maybe measure that one by, same thing, 5,000 feet, or we'll do, I don't know, we'll do 8,000 just to make it better to visualize. And there's something sort of cool when you do that. You get this option called side type, which is pretty neat, that you can actually either do a whole shape, or this option that comes up only for polygons that would say exclude the input polygon. And so the difference would be, if I just hit full, I would get a new shape that would be this shape, right? The polygon, and then 8,000 feet extended in its shape and direction. But if I were to do this option and say exclude the input polygon, what I'll get back is a shape that is starting at the edge and going out from the edge to 8,000 feet, right? It's almost like it'll create a donut. And that's sort of a neat concept here. You may want just that to see sort of the actual shape, which is the, the buffered ring, versus if you were to have picked, full as the option, you'd have a shape that more looked like this, right? The whole thing from this shape and sort of the area outside it would all be included. So the last thing that I don't want to go through on this video, this is more, if you're into it, I want you to sort of play around with it. You also have the ability to create multi-ring buffers, right? You can make buffers that have a 5,000, 10,000, X blah, 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 feet and create sort of these target-based ring patterns. But that is certainly something, if you're into, I encourage you to sort of explore yourself. For now, it's enough just to know buffers, to know how they look different with points and polygons, to know you can buffer distances and fields, and then to know its companion tool, which would be near, helping you understand what you're closest to and sort of how far away you are.